start even thinking about fractions, you need to know what partitioning means. It's a vocabulary word you're going to see a lot. What does partitioning mean? Kaden, what does partitioning mean?
Divide into equal parts.
Divide into equal parts. You can say pieces, that works too. Divide into equal parts or pieces. What's a really important word in that? That we need to make sure that we remember. Alyssa?
Equal.
Equal. It's very important that we know that equal is the most important thing. Just like when you're sharing, nobody wants to get the smallest piece. Everybody wants a fair share. Fractions are fair. Fractions are fair. I'm writing, therefore you should be writing. They're all about having equal sized pieces. If I got a pizza, me and Eleanor are going to take it on, eat the whole thing. Eleanor's not going to get one piece and I get 8 pieces. That is not equal.
You should get 4.
Okay, we're going to split it equally.
Like 4 to 4. So fractions are kind of like equal groups.
Yes, fractions are equal groups. Notice this word right here, Savannah. Do you remember what divide, what we did when we had to divide? What did we have to do, Savannah?
We had to take the number and put all in groups and then we go one at a time.
Could one group have 7 and another group have 2? No. So good call. We're dividing into those equal groups. You gotta have equal sized groups. We gotta be fair. Okay? Fractions are all about being fair. If you don't have this, please make sure it's written in your notebook. Alright, so let's think about what we did yesterday. We were partitioning pattern blocks. We have these pattern blocks and we're trying to use smaller parts to equally break up a larger pattern block. So let's review. Let's pretend that we have our blue rhombus. Here he is. And then we have some green triangles. How many green triangles are we going to equally partition that blue rhombus into? Okay, 2. We're going to take 1, cover them up there, 2, cover them up there. Is that equal?
Yeah.
Yes. My triangles are the same size. They are equal. Please put nothing on your hair. It does not look like a beauty spot. It's fine. You look great. Okay? So this is what we were doing yesterday for those who are not here. How many equal parts did we need to make a whole? Well, let me back up. What was the whole? Which pattern block was the whole? Peter, which one was the whole?
Rhombus.
The blue rhombus was the whole. And what was the parts?
The parts were 2 green.
Were the 2 triangles. Very good. So for those of you absent yesterday, this is what we were talking about. A lot of part whole stuff with fractions. So when we think about fractions, a lot of people get very anxious, like, oh my gosh, this is so new and so hard. It's a lot of equal groups. All of you guys are masters at equal groups. And it's a lot of part whole, which you've been doing for years now. Okay? So please don't stress that fractions are these crazy hard things. You have the pieces to figure out fractions. We just gotta put them in the right order in our brain. So let's think about, well, let's think about why in the world would I use fractions? We use partition a lot of things. What could I use fractions for? Think in your real life. What would you use fractions for? What would you use fractions for in your real life? Take a minute, turn and talk to someone at your table. What would you use fractions for? Alright, what are some things that I could use fractions for? You probably use fractions and not even know done it in your real life. Harley, what's one thing I could use fractions for?
Split up pizza.
Okay, so let's say I had a whole, could be pizza, could be brownie, could be a cake, and I'm splitting it into smaller pieces. I would need fractions to do that. Please write this down in your notebook. Alright? So if I had a whole pizza, or a whole cake, or a whole tray of brownies, kudos to you if you can eat all that, but most of us can partition it into smaller pieces, or split it into smaller pieces. That was where we used fractions. You're exactly right, Harley. How many of you thought something similar to that? How many of you were thinking along those lines? Yeah, that's a pretty common one. Mitchell, what's another way we could use fractions? Okay, talk to me a little bit more.
Like, if you have, like, usually the box will have what the puzzle looks like it's supposed to look like.
Okay, so each piece
Yeah.
is,
And you could, like, keep looking at it and then make the whole puzzle.
sure, that's another example of a whole. We have our whole puzzle, but we've split it up into a zillion pieces. Yeah, good example, good example. So we have a whole, and Mitchell's example of puzzle. Could have been a pizza, could have been brownies, and we've split it into smaller pieces. What else might be an example, James? Give me one.
Like a pie
Okay.
that you're splitting. If there was 5 of us, you would split it one.
We try to split it into equal parts. Yeah. Savannah, what else might we use fractions for? Okay, well, yeah. But I want to think more in real life, because your life is much more than the EOG. Yes?
Kind of.
Yes. No, 100%. Your life is way bigger than just the EOG. Eleanor, what else might I use fractions
Your
for?
mom might have given you, like, I don't know, 10 peppermints and told you to go share it equally with the neighborhood kids. And there's one other neighborhood kid there actually she gave you like 50 peppermints, and she says to divide it between the neighborhood kids and like their neighborhood kids.
Sure.
You would have to give it to
Yeah, so a lot of times when we think of fractions, we think of one whole. One pizza that we need to share out. So my pizzas are going to be smaller than a whole. But Eleanor's exactly right. We can use fractions if we have a lot of things. Broken into equal groups. So in Eleanor's example, she had peppermints, all these peppermint candies. Are you going to cut those peppermint candies into smaller pieces? No. No. So we're going to put them into equal groups. So fractions can both be taking something big and making smaller pieces, like a pizza or brownie or a puzzle. Or it could be having lots of things. Like I have 5 table groups, and I need 2 of them. I might say 2 fifths table groups. We need to do something like that. Am I breaking you guys up?
Blood will get out of us.
No, I'm not going to cut you guys up. That would be weird. But you can use fractions to separate things into equal groups. We already know how to do that. We just call it division. We know how to separate things into equal groups. We just called it division. It's the exact same skill. Okay? visual model. Yesterday we used pattern blocks. This is more of what you're going to see, a drawing. If you would please draw and shade that, that would be helpful. It's called a visual model. Okay, that's fine. Box, you can say that. So this is going to be the same thing. We had a huge square. That was our hole, one hole. And then we've broken it into smaller pieces. I broke it into smaller squares. Okay. Draw a quick drawing, doesn't have to be exact. How many parts are shaded? Not a trick question. How many parts are shaded? Peter, how many of these parts are shaded? One. One part is shaded. How many equal parts are in my hole? How many equal parts do I have in my hole? Alyssa? Four. One, four, five. Alright, so let's go back to these two vocabulary words. We have the numerator, which is the number on top of our fraction. We have that fraction bar in the middle, which we said looks like what operation? What operation does that fraction bar look like? Hint, hint, to kind of do the same thing. But looks very similar to the division side, but instead of dots, we have numbers. And then we have a denominator. Somebody who was here yesterday, flip back in your notes. Tell me, what does the numerator do? What in the world does the numerator do? Natalie, what does our numerator do? How many pieces am I using, or how many pieces are shaded? One. I want you to write this. One. What about denominator? What does our denominator stand for? What does our denominator stand for, James?
How many equals in a whole?
How many pieces do I need to equal a whole? How many pieces do I need to give me a whole? Four. So the fraction that goes with that picture, we're going to say 1/4. Please don't get in the habit, adults do this all the time, don't get in the habit of saying 1/4. Adults do it all the time, you're going to hear it. Okay? I would rather better math talk is going to say 1/4. Because if I say 1/4, 1/4. You see how that doesn't really mean a whole lot? You're gonna hear a lot of adults use that terminology. Just know that they probably really mean 1/4. Yes, ma'am.
When I was looking at this box, it reminded me of one of the questions, or a few of the questions on the math benchmark. There was like a big square, but then only part of it was shaded in, and I had to figure out
So what it was showing is I have one hole, and I've broken it into pieces. Maybe that hole was brownies, and this is how I cut all my brownies, and then the shaded ones are the ones that are eaten. You see what I'm saying? That's exactly how fractions work. All right, let's try another one. You're going to need to draw the visual model. This is our visual model. Draw it out. It doesn't have to be exact, just a quick sketch will work. I'm not too concerned. Alright, how many pieces or parts are being used? Not a trick question. How many pieces or parts are being used? Clean? Nope, I am not using 6. I am not using 6. You want to try that again? 1. Only 1 is shaded, Lee. So that's only going to be the one that I'm using. How many equal parts do I need to make a whole? Let's pretend that's not just a rectangle, but it's a sub. Oh, and I'm sharing it with my friends at a party. I need to partition it out. How many equal parts am I splitting that sub into? Okay? 6. I'm splitting that sub into 6 equal full parts. Same thing. Let's make a fraction to show what we're using. Numerator means what? Numerator means what? You should definitely know this by now. What does the numerator mean? You know what the numerator means. How many is shaded? How many are we using? What's going to be my numerator? 1. Still only using 1 in this problem. Only 1 is shaded. What does my denominator mean? What does my denominator mean, Matthew?
It means like how many are there?
How many? Not how many are there? A little bit. Getting better. It's not just how many pieces, but how many pieces does it take to make a whole? We got to go back to that whole. That's why it was so important that we defined what the whole was yesterday. So how many pieces, Matthew, are needed to make a whole? 6. Okay? That makes sense. Are there any questions? Matthew, what's up?
For if you were to put, if you shaded two rectangles, would it be two
What do you think? It would not be 2 and a 6. It would be 2, 6. So when you say a fraction, you add a TH usually on the end. For the most part, half is a little different, third is a little different, but for pretty much everything else, you say fifth, fourth, got that TH on the end. That's kind of a clue that we're dealing with fractions. Every piece of a fraction is called a unit fraction. You need to write that down because you're going to see that those words again. Every piece is called a unit fraction. And then every fraction that we might see is made up of these unit fractions. Okay. So think of it like a pizza. Every slice, I have 8 slices, every slice I would call a unit fraction. I need you to draw this model. So same model we just had, it has 6 boxes, but I've colored a little bit more in. Savannah, what's your question, dear? Alright, we're going to create the fraction that goes with this picture. Let's start with the numerator. How many pieces am I using? How many pieces or parts are shaded? Peter, how many am I using? 4. I'm using 4.
Out of 6.
I'm not going to say out of 6. I'm going to use the actual fraction term. I know there's 6 total that I need to make a whole. So it's going to be 4, 6. Now I'm going to show you what unit fractions might look like. So this piece is 1/6. This piece is 1/6. This piece is 1/6. This piece is 1/6. When I add 1/6 plus 1/6 plus 1/6 plus 1/6, I'm going to get 4/6. It's like saying 1 slice plus 2 slices plus another slice plus another slice is going to give me 4 slices. 1 slice, 1 slice, 1 slice, 1 slice. 1/6, 1/6, 1/6, 1/6. 1 brownie, 1 brownie, 1 brownie, 1 brownie. It's called a unit fraction because it tells you what you're counting. It's called a unit fraction because it tells you what you are counting. It is called a unit fraction because it tells you what you're counting. I'm saying that over and over and over again because
It's important and we can write it down.
So if I'm thinking about it as pieces, each piece is a sixth. So I know I'm counting by six. So my unit fraction is 1/6. What if my pizza was split into 8 pieces? My unit fraction would be eighths. I would count 1/8, 2/8, 3/8. You see what I'm saying? So your unit fraction is kind of like your unit. It tells you what you're counting. 1 slices, 2 slices, 3 slices. I might say 1/6, 2/6, 3/6. It tells you what you're counting. That's really important. You're gonna need to know that with fractions. Okay? Yes, ma'am. We're gonna do a little bit of independent practice. You'll probably need to turn to the next blank page. You're gonna draw. Don't spend all your time drawing. I'm going to draw a quick sketch of the different visual models that I have. I'll get that out of the way in a second. Then you need to tell me the unit fraction, which is the unit fraction, 7 unit fractions, and then tell me the correct fraction for the visual model. So let's do number 1 together. Go ahead and do a quick sketch in your notebook. You'll find that you will see round visual models, but I'm going to go ahead and tell you I hate them. I do not like circle visual models. Mostly because it's very hard to make equal pieces. It's a lot easier to make equal pieces with a square model or a rectangle model. Circle models are just very hard, which is why I really prefer if you don't use circle models. Alright, so got my first one drawn. Someone tell me for my yellow fraction, what's going to be my unit fraction sentence? Think back to what we were just doing with unit fractions. We were here. My unit fraction sentence. 1/6 plus 1/6 plus 1/6 plus 1/6 gives us the fraction of 4/6. Looking at number 1, what's going to be my unit fraction sentence? Matthew? 1/4 plus 1/4 plus 1/4 equals 3/4. Beautiful. This is exactly what you need to do for 1, 2, 3, 4, and 5. Okay? They need to be drawn. And you need to tell me the unit fraction sentence and the correct fraction. Let's start with number 2. How many pieces is this broken into? How many pieces is number 2 broken into? What's going to be my denominator for number 2? Corbin? What's going to be the denominator? Nope. I need to know how many pieces equal my whole for number 2. Are you looking at number 2? How many pieces do I need to get the whole thing filled up? Well, there's going to be more than 4. No, it's going to be more than 4. How many total do I need to get the whole thing filled up? You need 8 total, so 8 is going to be my denominator. Corbin, how many am I using right now? How many? I'm using 4. Alright, let's go back and count them. James, can you help me count them?
1/8
1/8
plus 1/8
plus 1/8
plus 1/8 plus 1/8 equals 4/8.
Beautiful. It's like saying 1/8 plus 1/8 plus 1/8
there's a
plus
lot.
1/8 equals 4/8. Does that make sense? Let's go to number 3. What's going to being my denominator, how many pieces do I need to make a whole? Lang, how many pieces do I need to make a whole? 3. And how many pieces am I currently using?
3.
Let's count the unit fractions. 1/3.
Plus 1/3.
Plus 1/3. 1/3 plus 1/3. So if you're having a hard time figuring out where these thirds are coming from, Corbin, 1/3 plus 1/3 plus 1/3 gives me a total of 3/3. Alright, let's look at number 4. Look at number 4. Ashlyn, what's going to be my denominator for number 4? It's going to be a 3.
And
Is it about number 4? Okay, well, let's get to number 4 and then we'll go through it, okay? Alright, how many pieces am I using though, Ashlyn? How many parts do I have shaded for number 4? 1. Alright, let's count unit fractions. 1/3. Do I have another third?
equals.
Do I have another third to count?
1/3 equals.
No, I just have 1. 1/3. I don't have anything else shaded, so it's just going to say 1/3 equals 1/3. James?
Confused on number 5.
Oh, well, what's the problem with number 5? What's confusing about number 5? Mateo?
Not equal.
So is this a visual model of a fraction?
No.
No, not a fraction. Fractions are all about being fair. Fractions are all about equal sized pieces. Number 5 is not a visual model, did you get your mail? Of a fraction. That's why number 5 is tricky. I'm glad some of you caught that. Number 5 is not a fraction. The pieces are not equal. Okay? Natalie, do you have a question? No? We good? Is that yes?
I was on number 2.
Uh-huh.
I was thinking like in commutative property with multiplication, you can switch the problem around. So can you like switch the shape around too?
What do you mean by that? Switch
Well,
the
like-
shape around.
In number 2,
Uh-huh.
it's sideways, but you can like
Vertical?
yeah.
Okay, so let's think about that question for a minute. So for number 2, the problem looks like this. And this is a great question, Lauren. What was it, 8?
Yep.
Yep, and then it's 4 shaded
Yep.
like this.
Yes.
Yes. Lauren wants to know, well, can we do this and still have what, the same fraction?
Yes.
All right, let's look. Okay. What's going to be the fraction for our first one? We already know this. We've already done it. What's the fraction for our first one, Kate? 4/8. We're using 4 pieces, and then if we need 8 pieces to make a whole, so we're using 4/8. What about over here? What's going to be our fraction over here? Riley? Yeah, I'm still only using 4 pieces,